Alright guys, so in this video we'll be looking at question 3 of March 206 past question, River State University. Alright, so the question 3 says, if the velocity v in kilometer per minute of a mop which starts from rest is given by this function, v is equal to integral from 0 to t 2x exponential x squared dx, is given by that integral at a fixed interval of time t in minutes for the first 1.2 minutes without converting to any other unit. The first question says compute the velocity to the first 1.2 minutes to two decimal places at t equals 0.2 minutes interval. The second question says, if the time is now fixed at t equals 1.2 minutes, estimate the approximation of the distance covered for the first 1.2 minutes to two decimal places using Simpsons 1/3 rule. And the third question says, approximate the value of g if the closed form solution of the distance covered is given by x equals 4.99 g. Alright, so let's start with the first question. Alright, so the first question says compute the velocity of the first 1.2 minutes to two decimal places at t equals 0.2 minutes interval. Alright, so to do this, first of all, you keep in mind from the question says you should not convert any of the units, so you're solving them like that. Now, second thing you keep in mind is you're not given any specific rule to use, hence we can use the trapezoidal rule to solve this particular problem. So I'm using the trapezoidal rule because it's quite easier for me to to evaluate the given function. Alright, so the trapezoidal rule simply states that the speed is equal to or equivalent to h all over 2 into f of 0 plus 2 summation I equal to 1 to n minus 1 of the given function f of xi plus f of t. Now, f of 0 simply means the function at the initial interval or the lower limit. That's f of 0. Okay, and then f of t means the function at the given upper limit, which is f of t. Whereas 2 summation I equal to 1 to n minus 1 of the function f of xi. F of xi stands for the given function at the intermediate intervals. Okay, now from the question, the condition was given that the question says we should find the velocity for the first 1.2 minutes to two decimal places at t equals 0.2 minutes interval. So the interval was given to us as 0.2 minutes. So we've already been given an interval then for the first 1.2 minutes. So which means this becomes the upper limit. Okay, that's the highest limit, 1.2 minutes. Then our interval should range from what? 0.2 being the interval. Okay, now the value of h here stands for what is called the interval width. Okay, and it was already given to us in the question. H stands for the interval width, and of course f of x, like I said, simply means the function at the intermediate interval. So it stands for what? The given function f of x. So we have from the question here, we have integral from 0 to t 2x exponential x squared dx. So this becomes the function. 2x exponential x squared becomes the function. So f of x equals 2x exponential x squared. So we are to now find f of x at the values of this function at the intermediate intervals. Now, how do we now get our intervals? Okay, so we need to start, remember from the question, it started from integral from 0 to what? The highest value of t. So that means this is actually what? Integral from 0, the highest value of t was given to us as 1.2 minutes, okay, of the given function 2x exponential x squared dx. But the interval limit was given to us, or the interval with h was given to us at 0.2. So which means we must start from 0 to get to what? 1.2. Hence, it means that your intervals become, okay, your intervals become from 0 to 0.2. So it must always be the difference between the final interval and the first interval must always give you what? 0.2. That's the interval limit, okay, or the interval width. So you have from 0 to 0.2, then from 0.2 to what? 0.4. Simply add 0.2 by 0.2. You have 0.4, such that 0.4 minus 0.2 also gives you 0.2. Your limit must remain within that interval limit, which is 0.2. It must remain within the interval width, which is 0.2. So 0.4 minus 0.2 will also give me 0.2. Then again, add 0.2 to 0.4. This will give me 0.6. And 0.6 minus 0.4 will give me 0.2. So you do this until you get to the highest limit, which is 1.2 for the first 1.2 minutes. So if I add 0.2 to 0.6, I will have 0.8. If I add 0.2 to 0.8, I will have 1.0, and if I add 0.2 to 1.0, I will have 1.2. So which is what we are asked. This is where we are going to end our analysis. So at the interval, the very first 1.2 minutes, so it starts from 0 to 0.2, 0.2 to 0.4, 0.4 to 0.6, and down to 1.2. And if you count, we have 1, 2, 3, 4, 5, 6, 7. Okay, so 7 total intervals. Now the interval width h, what h stands for, like I told you, means the interval width. It was given to us in the question as 0.2, but the other way to obtain this, or the other way to know this, is by simply saying 0.2 minus 0, that gives you 0.2, or 0.4 minus 0.2. Always you find out the upper limit minus the lower limit as you move along the line. Okay, so between 0.4 and 0.6, 0.6 becomes the upper limit. 0.6 minus 0.4 also gives you 0.2. So the interval width h is equal to 0.2. So this side is settled. So all we need to do now is look through the equation. This is our equation. We need to now find f of 0. F of 0 simply means, remember, the function itself, f of x, was given to us as, okay, I wrote it down here, but then 2x exponential x squared. This is the function. So we find the first thing to do, notice from the formula that we've not attached any coefficient towards f of 0 and f of t, where f of 0 means the function at the lower limit, f of t means the function at the upper limit. It is only the immediate intervals or the intermediate intervals that will actually attach what the coefficient to. So you have to be very careful of that. Okay, so we now find f of 0. This simply means that when x is equal to 0, that is at the lower limit, okay, from the lower limit, when x is equal to 0, then what is the function? F of 0 simply becomes, wherever you see x in the question, in the function now, put in the value as 0. So I have 2x here. It becomes 2 times x is 0 times exponential. I have x squared, and x is 0, 0 squared. So this becomes automatically 0 times anything becomes 0. So f of 0 is 0. So this gives me the function at the lower limit. Okay, that's the function at the lower limit. The next thing I would actually want to do is find the function at the intermediate limit. All right, so we now find after 0, the next interval is 0.2. After 0, the next interval is 0.2. So we find f of 0.2. So wherever you see f in the function, wherever you see x in the function, put in the value as 0.2. This becomes 2 times, I have 2 times x here, and x is 0.2 times exponential. I have x squared here, and x is 0.2 all squared. So I'm going to be computing all of this together at once. So go ahead and cross-check that to avoid any errors. Alright, so everything here gives me approximately 0.42. So guys, also do well to cross-check this with your calculator to ensure no errors. Okay, so that gives me f of 0.2. Next on the interval is 0.4. So we'll also find f of 0.4. So wherever you see x in the function, put in 0.4. So we have 2x. That becomes 2 times, in place of x is 0.4 exponential, I have x squared, which is 0.4 all squared, and this is equal to, just as usual, I'll compute all of them together just to save time. Okay, so I'll start by 0.4 squared. 0.4 squared, obtain a value for it, then take exponential of this answer. All right, multiply by 2, multiply by 0.4. So that gives me approximately 0.94. So this gives me 0.94 approximately. Next on the interval after 0.4, next is 0.6. So I'll also compute f of 0.6. So I'll find f of 0.6, and that's equal to, from the function, remember, 2x, which is 2 times x is now 0.6 times exponential x squared, and x is 0.6 all squared. So I will also compute all of these at once. So I will start by 0.6 squared, obtaining a value for that, 0.6 squared. Okay, then I will take exponential of the that answer, multiply by 2, multiply by 0.6, and that gives me approximately 1.72. So I have this to be 1.72. After 0.6, next on the interval is 0.8. So I will compute f of 0.8, and this is equal to, remember the function, 2x, so that's 2 times x now is 0.8 times exponential x squared, and x is 0.8 all squared. This is now equal to, so I will also point all together, starting by 0.8 squared. Find the exponential equivalent of that value, multiply by 2, multiply 0.8. Okay, this simply gives me 3.83 approximately. I have 3.83. Next is, after 0.8 we have 1.0. So we'll find f of 1.0, f of 1.0, and that's equal to, remember the function, 2x exponential x squared. It becomes 2, x is now 1 times exponential x is 1 all squared, and this is equal to, I will also point all of this, exponential 1, okay, multiply by 2. This gives me 5.44 approximately. I have 5.44 approximately, and after 1 we are now on the final, which is what, 1.2. okay, the final interval, so f of 1.2, and this is equal to, remember the function, 2x exponential x squared. That becomes 2x is now 1.2 times exponential 1.2 all squared. Now this is equal to, okay, so I will also start by 1.2 squared, find the exponential equivalent of that answer, multiply by 2, multiply by 1.2, and this gives me approximately 10.13. So I have 10.13 approximately. So after getting all this, all you need to do is what? Put in the whole of these values into the equation for velocity. It's as simple as this. The velocity is equivalent to this. Okay, so let me state back the formula here. We have that the velocity is equivalent to the width all over 2 divided by f of 0 plus 2 summation I equal to 1 to n minus 1 of the intervals function plus f of t, which is the upper limit, function of the upper limit. And it's as simple as this. So it means that velocity is equivalent to the interval width. Remember, we obtain h to be what? 0.2. That's the interval width, 0.2. So we'll put it back into this equation. So we are going to have now 0.2 all over 2, remember h all over 2, into f of 0 gave us 0 earlier. We got f of 0 as 0. So if we have f of 0 as 0, this is now equal to, in place of f of 0, we have 0 plus, now 2 times the summation of the intervals, in intermediate intervals. So we take note, not the last is not inclusive. So it's 2 times summation of the what? Intermediate intervals that we've gotten for the function. So it becomes 2 times, so the intermediate intervals begins from 0.2. After 0, the next is 0.2. So from 0.2 down to 1.0 is the intermediate interval. So we sum their values. Remember we had here 0.42, we put it down, 0.42 plus, next we have 0.94, we also put it down, 0.94 plus, next you had 1.72, you also put it down, 1.72 plus, next you had 3.83, you put it down, 3.83 plus, next you have 5.44, 5.44. I think that's the end of the intermediate, plus now the final function of the upper limit would give us 10.13. So plus 10.13, that becomes your solution. So let's compute all of this. Okay, velocity is equivalent to 0.2 divided by 2 will give us about 0.1. So we have that to be 0.1. Okay, 0.1 multiplying all through. Of course, this is 0 plus. Now this is 2 times. I will add up everything in this bracket. I have 0.42 plus 0.94 plus 1.72 plus 3.83 plus 5.44. The whole of that summation gave me 12.35. Alright guys, also do well to confirm these solutions. Okay, 12.35 plus, okay, I put down my last value here, 10.13. Okay, now this is equal to 0.1 multiplied by, of course, 0 plus anything here is off, so I will multiply this in bracket now by 2. So I have 12.35 times 2, that gives me 24.7. Okay, 0 is off, so I have 24.7 plus, remember I have 10.13 here, 10.13. Okay, alright, so after obtaining this, it means that the velocity is now equivalent to, remember, 0.1 multiplied by 24.7 plus 10.13. Alright, so 24.7 plus 10.13, this gives me 34.83. So I have 34.83. Okay, so from here now I can simply find that the velocity is approximately equal to 0.1 multiplies 34.83, that gives us 3.483. So I have 3.483. Remember the unit remains kilometer per minute, so we're asked not to convert. So this is now the value of the velocity, okay, solved by the use of trapezoidal formula or trapezoidal rule. Okay, so the second part of the question, the second part says if the time is now fixed at t equals 1.2 minutes, estimate the approximation of the distance covered for the first 1.2 minutes to 2 decimal place using Simpsons 1/3 rule. Okay, so we start this now by stating Simpsons 1/3 rule. Simpsons 1/3 rule okay simply states the integral of a function from a to b of a function f of x, the x is simply equal to xn, where Sn is equal to the width all over 3, okay, into f of a plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus 2 f of x4 and so on down to f of b. All right, so this is Simpson's rule. Now, what is the rule saying? First thing is you find the given the function at the lower limit, that's f of a. Also find the function at the upper limit, that's f of b. But now notice that in between the intervals, we have what? We start from 4. F of x1, that's the first interval after the lower limit. Then it alternates from 4 down to 2. It becomes 2 f of x2 for the second interval, back to 4, 4 f of x3, and then 2. So it continues like that depending on the number of intervals you have in the question. Now for this question, we've been given to evaluate. We were given that v is equal to integral from 0 to t, which is the upper limit of 2x exponential x squared dx. This is the question we're given, and we're asked to find distance. This is now equation for velocity, but we know that distance covered, d, is simply what? Velocity times time. This gives us distance, so it means that to find the distance, okay, d is simply equal to the integral from 0 to t velocity times dt. This will give us the formula for the integral. Now, we were asked in the question to estimate the approximation of the distance covered for the first 1.2 minutes. Okay, for the first 1.2 minutes. So, which means we also have to find what? The intervals. Now, the beautiful thing about Simpson's rule is that you choose your hand, or you by yourself choose the number of intervals you want. But you must always have it in mind that the intervals must always be an even interval. You cannot have an odd interval. And it's either 2, depending on if the question is just in this form. But then, if it has a larger number in which you have to find intervals, of course, you can move from 2 down to 4, down to 6, but have it in mind that the interval must always be an even interval. Now, in this question, we've been asked to find the integral from 0 to the maximum time is 1.2 minutes of the velocity times dt. This gives us the distance. And the time, maximum time is 1.2 minutes, okay, indicated here already. Now, we need to find the intervals. So, like I told you, the number of intervals you choose by yourself. Now, this h here stands for the width, and the width, the interval width, h, is given as the upper limit b minus the lower limit a all over n, where n stands for the number of intervals. And I told you that intervals must always be an even interval. So let's now say the interval should be what? 4. So let n, number of interval, be equal to 4. So it means you're going to split from 0 to 1.2 into what? 4 different intervals. The maximum time there is 1.2. So you must split it into 4 different intervals. All right, so first of all, let's get our width. Therefore, our interval width is now equal to upper limit is 1.2 minus lower limit is 0 all over number of interval we've chosen 4. So this is approximately 1.2 divided by 4, and 1.2 divided by 4 will give us 0.3. So it means that the interval must not exceed 0.3. So all you need to do is, starting from 0, you add up 0.3 down to what? Till you obtain 1.4, and it must be of what? 4 intervals. Now let's try it and see. Therefore, the interval becomes now from 0 first to 0.3. Now add 0.3 to 0.3, you have this to what? From 0.3 to 0.6. Add 0.3 to 0.6, it becomes from 0.6 to 0.9. Add 0.3 to 0.9, you have to what? 1.2. Now let's check. From 0 to 0.3 is the first interval, 1. From 0.3 to 0.6 is the second interval, 2. From 0.6 to 0.9 is third interval, 3. From 0.9 to 1.2 is the fourth interval, 4. So which means we are in order. All right, so we have this. So all we need to do, just like we did in the previous the previous question, we need to now find each of these function. This is the function or function at, we have to find the function at the lower limit, find the function at the upper limit, which is 1.2. Then we'll have to now alternate 4, 2, 4 for the intermediate limit. All right. So first thing to do is we find f of 0, which means when x is 0, put in the value as x equal to 0 into the function. Now, what is the function? Remember, we've already done that earlier. Y is equal to, f of x or y is equal to 2x exponential x squared. This becomes the function. So f of 0 simply means whenever you see x, put in the value at 0. So this is equal to 2 times x is 0 times exponential 0 all squared. And of course, 0 multiplies everything here, gives you 0. So you have that. Next is to find f of x1, okay, from the formula which I've stated there. So I call that f of x1 from the intermediate intervals now. So we have f of x1, and x1 there is 0.2, sorry, 0.3. So which means whenever you see x, put in the value as what, 0.3. So this is actually saying f of 0.3. So this is equal to 2 times, I have x here from the equation x, and x is 0.3 exponential. I have x squared and x is 0.3 all squared. So I'm going to compute all of this together just to save time. So I'll start by 0.3 squared, take the exponential function of that value, multiply by 2, multiply by 0.3. This gives us 0.66 approximately. So I have 0.66. Next, I'll find f of x2, which is now the next interval, which is 0.6. It becomes f of 0.6, which is now equal to 2x, remember, and x is 0.6 times exponential 0.6 all squared. So this is equal to, so I'll punch everything at once. So do well to do something to confirm accuracy in calculation. So 0.6 squared, I'll find exponential equivalent of that function, multiplies 2 multiplies 0.6. This gives me 1.72. So I have this whole function to be 1.72 approximately. Next is what, 0.9. So I will find f of 0.9, and this is equal to, remember, 2x, so 2 times 0.9 times exponential 0.9 all squared, and this is equal to, okay, so go ahead and punch all together, 0.9 squared. I'll find the exponential equivalent of that function, multiply 2 multiply 0.9. So this gives me 4.05. Approximately I have 4.05. And finally, the last is what, 1.2. So I'll find f of 1.2, and this is equal to, I'll have here 2x, and x is 1.2 times exponential 1.2 all squared, and this will give me, okay, so 1.2 squared. I'll find the equivalent of the exponential of that function. I'll multiply by 2, multiply by 1.2, and this gives me 10.13 approximately. So I have here 10.13. Okay, so I can now plug into the Simpsons rule. From Simpsons formula, Sn is now equal to, remember, we said h, and h is what, the interval, the width interval, and the width interval was given to us here 0.3. So we have h all over 3. So this simply becomes 0.3 divided by 3. Okay, 0.3 divided by 3 multiplied by, remember the formula, first is what, f of 0. So we have it here, f of 0, and we've already obtained a value for f of 0. F of 0 gave us 0. So simply 0 plus, now you start alternating, okay, between 4. So for f of x1, you have 4 times f of x1, which is the very first element or the very first function after f of 0. You have it to be what, 0.66. So it becomes 4 times 0.66 plus, next is 2. You have 2 times f of x2, and f of x2 gave us here as 1.72. you have 1.72. You fall back now to 4, so it becomes 4 times. The next value there is what? 4.05. You have 4.05 plus. Now, what you have is now the final limit, so you cannot multiply by 2. So it's always the first limit remains, the function at the first limit, and the function at the last limit. And the function at the last limit gave us 10.13. So you simply put it down as 10.13. You end your Simpsons rule there. Alright, so xn is now equal to, so let's obtain 0.3 divided by 3. That gives us 0.1 into, and of course, this is 0 plus. Now let's obtain 4 times 0.66. 4 times 0.66. That gives us 2.64. We have that to be 2.64. Okay, we have 2.64 plus. Next we'll find 2 times 1.72. 2 times 1.72. That gives us 3.44. We'll have here 3.44 plus. Next is 4 times 4.05. So we'll find 4 times 4.05. That gives us 16.2. We'll have here 16.2 plus. Finally, we have 10.13. You close up. So xn is equal to 0.1 multiplied by, let's add up everything now. So 10.13 plus 16.2 plus 3.44 plus 2.64. Everything here gives us 32.41. So we have 32.41. Okay, so multiply that by 0.1. This simply implies that Sn is equal to, multiply by 0.1 now, times 0.1, and we have 3.241. Alright, so this becomes okay, xn and n is 4, so appropriately you're saying x4, okay, is equal to 3.241 in kilometers. That becomes the value of the distance covered using Simpson's rule for that particular question. Okay, so that's the second question. Now the third question. Says, okay, I. Alright, so the final question says, approximate the value of G if the closed form solution of the distance covered is given by x equals 4.99 G. So it's very simple. We've already gotten the value of x. Recall, we've already gotten x4 to be equal to, that's the value we got previously, 3.241. Okay, we've already gotten this value to be equal to 3.241 in kilometers. So this simply implies that if you substitute here, 3.241 is equal to 4.99 G, and therefore you can make G subject by dividing through by 4.99. It becomes 3.241 over 4.99. This implies that G is equal to, you have 0.65. So G is equal to 0.65. Alright, so that becomes the answer to question 3. So that's question 3 in all. I will see you in question 4. Thanks and cheers.